Hello, everyone. And in this video, we're going to specifically talk about dividing polynomials. So we've kind of done a lot of operations on polynomials so far. We have learned how to multiply polynomials. We've learned how to add and subtract polynomials. And the last thing to really discuss is how to divide polynomials. So there are going to be two strategies that we work on today. We're going to have long division of polynomials and then synthetic. So let's jump right into it. The first strategy we're going to talk about is long division. And this goes back to like how we used to do long division with just numbers, only the difference is now we're going to use polynomials. And there's a couple different parts. So there is a divisor, a dividend, a quotient, and a remainder. So whenever we do division of polynomials, whether it's long division or synthetic, we will always have what is called a divisor, which is what we are dividing by. And it's usually the short polynomial. Actually, it will always be the short polynomial. Then we have what's called the dividend. And this is the long polynomial, or the longer polynomial. And it's what we are dividing. Now, when we perform our division, we're going to end up with a quotient and a remainder. The quotient is the remaining polynomial, and the remainder is basically just the last part of the remaining polynomial, if there is any. And when we do division of polynomials in the long division way, the way we actually divide it is we're going to take our dividend on the inside, and I'll show you with an example, two examples. Dividend goes on the inside, the outside goes our divisor. We perform a bunch of long division of this times something here matches our dividend, and the resulting value up here is what we call our quotient. Here we do a bunch of math, subtractions, repeated over and over again. And then we get a result. We do some math, subtractions, and finally we end up with a number value. Here it could be 0, it could be a number, and this is our remainder number value. So I'm going to show you two examples of how to use long division. Then we'll talk about the faster, quicker, much more loved way of synthetic division. And the long division and synthetic always have a divisor, a dividend, a quotient, and a remainder. And then you guys will have an assignment where you get to decide how you're going to divide these polynomials. So let's jump into it. Long division. So let me just give you like specific examples so you can kind of see what I'm talking about. You might kind of get a vibe for what I'm doing here, but it's really hard to tell unless we actually have an example. So let's divide 10x to the third minus 10x squared minus 26x plus 12. Let's take this first polynomial and divide it by x minus 2. So the longer polynomial is always going to be my dividend. So this is my dividend. My shorter polynomial will always be my divisor. And the way I set up my long division is I put my dividend inside and my divisor on the outside. Sorry, there's a glare in here that says x minus 2. So my divisor goes on the outside. X minus 2 goes on the outside. My dividend goes inside. I don't know how I always remember. The divisor's on the outside, short one on the outside, long one on the inside. Divid end, like it kind of sounds like dividend, like inside. And we line it up 10x to the third minus 10x squared minus 26x plus 12. And you guys are going to want to pay close attention. In order to perform this long division, my goal is to figure out what do I multiply to match the first term. What must I multiply times x minus 2 to match the first term? So I always start off by writing the first term. So x times what is 10x to the third? That would be 10x squared. 10x squared times x is 10x to the third. So I give myself a little check mark. Now I have to also multiply this by the second part of my polynomial. So 10x squared times negative 2 is negative 20x squared. And I write that down. But the really most important thing is that these two numbers match perfectly, because then I'm going to have to subtract them. 10x to the third minus 10x to the third is nothing. It's exactly what I wanted. Negative 10x squared minus negative 20x squared, negative 10 minus 20x squared becomes negative 10 plus 20 becomes 10x squared. And I'm going to drop down the next term, minus 26x. Then I'm going to repeat the process. I'm going to start here and say x times what gives me 10x squared. Remember, I want to match 10x squared. So I have to say x times 10x. 10x times x is 10x squared. And then 10x times negative 2. 10x times negative 2 is negative 20x. And subtract. What's hard about long division is we're always subtracting, right? 10x times x is 10x squared. 10x times negative 2 is negative 20x. 10x squared minus 10x squared is nothing. That's exactly what I wanted to do. Negative 26x minus 20x. Negative 26x plus 20x, if you will, is negative 6x. And drop down the plus 12. Again, repeat. Start over. X times what is negative 6x? Well, x times negative 6 is negative 6x. And remember, I have to multiply negative 6 times x and negative 6 times negative 2. Negative 6 times negative 2 is negative 12. Subtract off this polynomial. Negative 6x plus 6x is nothing. 12 minus, this should be plus 12, sorry. A negative times a negative is positive. 12 minus 12 also gives me 0. So in this example, 0 is my remainder because there's nothing left to drop down. There's nothing else to multiply. And this value up on the top, this is my quotient. So if you get a remainder of 0, that means that your polynomials divide evenly. Just like 5 divides 10, there's no remainder. In this instance, this polynomial does evenly divide 10x to the third minus 10x squared minus 26x plus 12. So we say that the quotient times the divisor is equal to the dividend. Is basically what it is. We found a factor of the polynomial. So we say that x minus 2 times 10x to the third minus 10x squared minus 26x. Oops, I'm sorry. My divisor times my quotient, 10x squared plus 10x minus 6, is equal to my dividend. So if I multiplied these two polynomials together, I would get 10x to the third minus 10x squared minus 26x plus 12. So that's my first long division where they divide nicely. But what happens when it doesn't divide nicely? So we're going to repeat the process, and the process is the same, but in the next example, we're not going to get an even, it's not going to divide perfectly. It's not going to have a remainder of 0. So let's try it out, but we still will have a dividend, we will still have a divisor, and we will still be repeating this division algorithm, if you will, where we're matching our very first terms, subtracting them off, dropping our next term down. So the next example that we're going to do is the following. We are going to take 5x to the fourth minus 59x to the third plus 86x squared plus 45x minus 53, and we're going to divide this by x minus 10. Again, remember the long polynomial is always the dividend. The short polynomial is always the divisor. So to perform this long division, we are going to have our divisor on the outside, the short one, x minus 10 on the outside. And my dividend goes on the inside. So 5x to the fourth minus 59x to the third plus 86x squared plus 45x to the first minus 53. It's important that this is in standard form so that we are able to do this correctly. Let me move out of this light here. All right, and our goal is to always match the first term. I'm trying to figure out what times x minus 10 matches the first term. So 5x to the fourth it is. X times 5x to the third is 5x to the fourth. And 5x to the third times negative 10 is negative 50x to the third. Subtract. 5x to the fourth minus 5x to the fourth is nothing, 0. That's exactly what I wanted. Negative 59x to the third minus or plus 50x to the third is negative 9x to the third. And drop down my next term, 86x squared. Start over. I need negative 9x to the third. So x times negative 9x squared gives me negative 9x to the third. Negative 9x squared times negative 10. Negative 9 times positive 10 is positive 90x squared. Subtract. Negative 9x to the third plus 9x to the third is 0. 86 minus 90x squared is negative 4x squared. Drop down the next term and start over. That says 4x, negative 4x squared plus 45x. Okay? So x times negative 4x is negative 4x squared. Negative 4x times x is negative 4x squared. And negative 4x times negative 10 is plus 40x. Subtract. Negative 4x plus 4x gives me 0, exactly what I wanted. And 45x minus 40x leaves me with 5x. Drop down negative 53. Okay, start over. X times 5 gives me 5x. And 5 times negative 10 is minus 50. Subtract. 5x minus 5x is nothing, exactly like I wanted. Negative 53 plus 50 leaves me with my remainder of 3. So sometimes you get a remainder of 0, meaning it divides nicely. Sometimes you get any number at all, and that's your remainder, meaning it does not divide nicely. But we can still write these two things as a product, believe it or not. So we'll talk about a factor theorem at the end of this week and kind of what this tells us, how to use these division things to tell us more about what is happening to our polynomial, but we have a remainder. So I can say that this does not divide nicely. But I can still say that 5x to the third minus 9x squared minus 4x plus 5 plus my remainder over my divisor is my entire quotient. So the way we would write this is we could technically say that my quotient plus my remainder over my divisor times my divisor gives me my dividend. But it does not divide nicely. So if I did divide, I end up with this. The way I know it's a remainder is it has this ugly piece here, or just this value, this number other than 0. Cool. So now let's talk about synthetic division, which is the faster way to do this same process. Okay, synthetic division is faster. Someone developed it to make this process a little bit long because, especially with subtracting these values, it can get a little tedious. If you forgot to, distribute the negative here, you might have had negative 103 or something as your remainder. If you mess up your multiplication from this part of your quotient times the entire part of your divisor, that can get you all jacked up. So someone actually created synthetic division as an alternative. So let's talk about synthetic, which I think you guys are all going to fall in love with synthetic division. Okay, so we have synthetic division, aka the shortcut. But there's something you have to know. Okay, in order to use synthetic division, your divisor must be in a linear term. It must be in the form, so your divisor must be in linear form, meaning it's in like x minus a. Okay, there's no number in front of x. If it's not, when you perform synthetic division, your quotient will be off by a factor of whatever this number is, and so you have to account for that. So it's just easier if we say that your divisor must be in linear form. And synthetic division only works with numbers. There's no x's here when we do synthetic division. And lastly, first of all, our divisor has to be in linear form. It only works with numbers. And having a brain fart. We must use, 0 as a placeholder. For missing terms. So that is really, really, really important. And the way synthetic division is going to look is we're going to have a little bit different setup. We're going to have the coefficients of the divisor of the dividend on the inside. Our divisor number only on the outside. And we're going to perform some math on the inside, drop some values, and get our quotient and remainder. So it looks a little different, but it's much nicer. So let me just give you an example, and you will see how lovely synthetic division is. The divisor number goes on the outside, dividend goes on the inside. I'll talk about how to do this math, and our quotient is represented by numbers here, and the remainder is just the last number at the very end of your synthetic division. So what if I wanted to divide, let's take x to the 4th plus 14x to the 3rd plus 48x squared plus 9x minus 30 and divide it by x plus 5. We know the longer polynomial will always be our dividend. Our shorter polynomial will always be our divisor. And our divisor must be in linear form, right? x minus a or x plus 5. That's fine, as long as there's no number in front of the x. Now, synthetic division only deals with numbers. So the catch is our divisor has to be set equal to 0. And you get x equals negative 5 as our, I like to call this, it's not really in a box, but I like to call this my box number. X equals negative 5. I apologize about the glare up above. Not ideal. So now, when I'm performing my synthetic division, I take just the coefficients of my dividend. So this is going to be 1, 14, 48, 9, and negative 30. 1 from x to the 4th, 14 from x to the 3rd, 48 from x squared, positive 9 from x, negative 30 from our constant term. Our divisor number goes on the outside, which is negative 5, or my box number. And here's how synthetic division works. Pay close attention, okay? The first number always drops down, no matter what. They would always do an arrow. The first number always drops down, okay? Now here's the trick. Here's what's different and what's so fast and nice about synthetic division. Whatever number appears in this line is going to be multiplied by your box number. So 1 times negative 5 is negative 5. And that's what I write directly in the next spot. Here's the cool thing about synthetic division. You add vertically. So 14 plus negative 5. 14 minus 5 gives us 9, right? 14, 13, 12, 11, 10, 9. And I start over. Any number that appears in this line multiplies by the box number. So 9 times negative 5 is negative 45. I write it in the next spot, and I add vertically. I add vertically. Okay, so that's what those little plus signs are. I add them vertically. 48 plus negative 45 leaves us with 3. Okay, 48 minus 45 is 3. Start over. 3 times negative 5 is negative 15. Add vertically. 9 minus 15 is negative 6. Whatever ends up in this line starts over. Negative 6 times negative 5 is positive 30. Negative 30 plus positive 30 is 0. Okay? This final number right here is my remainder. This is my remainder. And this is my quotient. Now, since I'm divided by a linear term, so I did x to the 4th divided by x, this will always be 1 degree less than my dividend. So this quotient corresponds with 1 x to the 3rd plus 9x squared plus 3x minus 6. This is my quotient. This is my remainder. And this does divide nicely since my remainder is 0. So I would say that my quotient times x plus 5, my dividend, is equal to my divisor, which was x to the 4th plus 14x to the 3rd plus 48x squared plus 9x minus 30. And I could verify that by checking my polynomial multiplication, but since the remainder is 0, I know that will be true. Let's do one more example where the remainder is not 0. Okay, so remember, synthetic division is a shortcut. This was much faster, way less writing and much faster to actually perform this long division of just as long polynomials. So let's do another example. There will still be a dividend, there will still be a divisor, but this time our remainder will not be 0. Same rules apply. Okay, so here we're going to have x to the 5th minus 2x to the 4th plus 7x squared minus 12x minus 6, and divide this by x minus 2. So I'm going to have my dividend and my divisor. Remember, I set my divisor equal to 0 as long as it's in linear form, which it is. I get x equals 2 by adding 2 to both sides, is my box number. So I write, you can even write x equals 2 on the outside if you would like. And my dividend goes on the inside. Now remember, I have to use 0 as a placeholder if I'm missing a term. So my dividend, right, is x to the 5th. The coefficient of x to the 5th is 1. Minus 2x to the 4th is minus 2. There is not an x to the 3rd term. X to the 5th, x to the 4th, x squared. It's missing x to the 3rd. So I need a 0 placeholder. I absolutely have to have this placeholder with synthetic division. Long division, you can get away without having the placeholder. You just have to be a little careful. Synthetic will fail if you do not use a placeholder. So x to the 5th, x to the 4th, x to the 3rd, x squared coefficient is 7. X to the first coefficient is negative 12, and the constant term is negative 6. Okay. Again, the first term always, always, always drops straight down. And now we start the process. Anything that appears in this line gets multiplied by our box number. So 1 times 2 is 2, add vertically. Negative 2 plus 2 is 0. Start this number times our box number. 0 times 2 is 0. 0 plus 0, add vertically, is 0. Start over. 0 times x equals 2 is equal to, it is equal to 0. Okay, put it in the next spot, add vertically. 7 plus 0 is 7. Start over. This number, 7, times my box number 2, 7 times 2, is 14. Add vertically, negative 12 plus 14 is 2. Start over. 2 times 2 is 4. Negative 6 plus 4 is negative 2. And I'm done. I didn't have to do subtraction. I didn't have to do anything crazy. My remainder is -2, meaning it does not divide nicely. And my quotient, since I divided by a linear term, my quotient will always be 1 degree less than my dividend. Since this was x to the 5th, this is going to be 1 x to the 4th plus 0 x to the 3rd plus 0 x squared plus 7x plus 2 with a remainder of -2. Okay, now I can clean this up in my quotient. The zeros go away. I really have x to the 4th plus 7x plus 2. This is my quotient. And my remainder can be added on and divided again by our divisor. I know that this does not divide nicely because I have a remainder, but I still can write my quotient, the total quotient, as x to the 4th plus 7x plus 2 minus my remainder over my divisor. Now we'll talk about what all of this means at the end of this week, hopefully live, not on a video. But for right now, I just want you guys to get down the process of dividing polynomials with long division and synthetic. I am going to ask that you practice both, but on the exam, I will let you choose. There's pros and cons to both. All right.